In this problem, 40 combination sum number two, we are given candidate array and a target number, and we need to find all unique combination in candidate, where the candidate number sums up to target. Each number in candidate may only be used once in the combination, right? So that means we cannot repeat a number if it is not there. So 1 and 1, two of them are there, so we can only use maximum of two or 1. 10 is there, so only one. For 2, we can only use once. So we can say, hey, can we use this two once here? Yes, but then only we can only use the maximum occurrence, right? So after we use it, we cannot use it anymore. For this one, number of 2 is there, so we are using double time, so that's fine. So the maximum number we can use, each number in candidate may only be used in once in the combination. Okay. For this, what I want to do is have a frequency and make it as an array, right? Frequency array, and then I can say how many time I'm using it, and then return the result. Uh, it is similar to number 39 problem that we did. Uh, so uh, we can look into this problem. Um, okay, so the solution must contain a duplicate, must not contain duplicate combination. So let's say result is over this, right? And what we can do is frequency equals to this. Let's say frequency equals to actually let's do counter of candidate. So this will give us, if this was our array, then this will give us the, let's say 10 equals to 1, 1 equals to 2, 2 equals to 1, 7 equals to 1, 6 equals to 1, and 5 equals to 1, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, right? 1 is duplicated. So from this, what I want to do is counter just a frequency map, right? And from this, I want to convert this to array, which is number, comma, counter. Okay, so number, comma, counter will have our array, let's say. So candidate equals to um, num, comma, count for num, comma, count in frequency dot item, right? Item, right? So if you look at this, it will have number is 10, right? Number is 10 and value will be 1. So if we just now print this array in candidate, candidate, okay. If we just do this elements elements, no, no, actually it need to be, yeah. So it is items, okay. So 10 comma 1, 1 comma 2, 2 comma 1, and the order might be anyway, right? So as this is a hash map, the order is not known in the beginning, okay. uh, Candidate is there. Now the idea, this is what I was trying to show. So now the idea is we want to go through this array from start, okay, and try to add this number, count number of times, okay. Well, we want to add it to 0 times, 1 times, 2 times, until the count time, and then loop it again. And if we find a target, then that's our result. Okay. So Okay, so now let's describe a function. Let's call this function combination helper, right? Helper of self, comma, candidate, comma, partial, and start, right? And target. Okay, as of now. Okay, if target equals to equals, also we need result, obviously. Also result. If target equals to zero, if target equals to zero, then what we can do, right? What we can do is a result dot end of a list of partial. Okay. If we are at the end and we found a solution that result our target being zero, then we found our solution. Return, right? If target is less than zero, if target is less than zero, that means hey, we already have too many elements on our partial array, so remove it, right? And now else, right? For I in range start, uh, what we can do in this case is, now let's say my start is at index this 0, so uh, our array was 10 comma 1. Now based on the frequency, what I can do is I can either add 1 times, 2 times, or 3 times, right? So if start equals to len of uh, candidate, then what? Return it, right? I'm at the end and I don't have anything there, so I can return it, right? Now, our counter is candidate at start index, okay? At 0 comma 1, right? Because our 1 contains our count, okay? So now what I want to do is for I in range counter plus 1, right? Because 0 is also there. So now what we can do is add this number this many times, right? I number times. So uh, partial if I times the number of frequency times the number that we are looking at is what we can do is actually number comma counter equals to start, right? So our 0 will have our number and our counter will have our count. So if I comma number is less than target or less than or equals to target, then what we can do is partial partial. Uh, what we can do is uh, partial dot append of. Actually, we can do this. Actually, I don't want to append I number of times because this might be confusing. So what we can do is combination helper. Okay, self combination helper of candidate comma partial is partial plus I times number, right? So we are creating an array of size I. It will start from 0 to counter plus 1 counter, right? So I'm saying if the value of I times number is less than target, then append the partial and number, and candidate is candidate. And start is start plus 1, right? And target. Target is also important. So target minus I times number, okay? And result is our result array. After this, I think this is all. Uh, combination helper, uh, self, right? So self combination helper, candidate, comma, partial, comma, start from 0, and partial, actually partial should be an empty array at first. Start is start, target is target, and result is result, right? And then we can do return result, right? Expected this online if okay, yeah. If I times number is less than target, then do this. Okay, so 2617125 116. So submit. Okay, there you go. Obviously, in this case, we can also do this because here we are checking if it is target is less. So this is also not required in a way. This is required because I didn't want to access index directly if it is at the length of an array, if we are out of the array. So we can also do this. So that should also be fine. Yeah.